So this tutorial is about coding style. We swapped the debugging tutorial with the coding style because we want you to get used to write with a fixed coding style at an early stage of your coding cycle. Why does code style matter? Your code is written once, but read many times, modified many times, often not by the original author. So it's very important for you to write code that is easy to read and understand. Code which is hard to read is bug prone. You'll have to do more debugging, spend more time in the debugging stage to figure out what's the bug. It will be difficult to modify by others because everyone needs to understand it first. And it's challenging to reuse. Today, I'm going to cover the guiding principles on coding style and some aspects of coding style that you need to follow in your milestones, and this will be graded by your TAs. Functions, variables, comments, avoid duplicate code, group data with classes and structs, no warnings. Up to here, your TAs will be grading according to the guidelines covered in this tutorial, and afterwards, self-checking code are optional and others not covered. Guiding principles on coding style. Reduce cognitive load while trying to understand your code. Programming requires understanding a lot of details. When you're reading a code, you will need to, in your head, memorize what variables are in the scope right now, what are you doing right now, and what are the algorithms, for example. Human working memory is, according to Miller's law, 7 plus minus 2 items. And that is the most a human can remember at one time. So if you need to let your reader do more memorizations, it will be very difficult and it will spend much, much more time trying to read. So try to minimize the number of considerations at a time. Explain why by your coding style. Your code itself explains how, but usually not why. Original writer understood, but usually can't ask them, or the original writer might forget about why you choose to write the code like this. Usually when I'm reading a piece of code that's not written by me, I'll think there's another way of writing this code. Why are we choosing this way but not the other way? And I have to ask the original writer if it's not already commented in the code. Functions, variable names, temporaries. First, functions. You need to make your functions short. Most functions should be 40 lines or less, according to Google. And in your milestone, we'll ask the user to check whether your functions can be kept within one screen. If it has to be more than one screen, you will need a very good reason for that. Long functions are hard to read, understand, and maintain. If you need to keep your short functions short, you will be forced to name parts of code into helper functions. And therefore, it helps you organize and structure your code, and your helper functions may be reused later. Functions will overgrow over time. If every time you think you just need to add 2 more lines to this function, over time, after 10 times of I just need to add 2 more lines to this function, it's 20 more lines. So refactor to extract new helper functions if this happens. Variables. Good variable names describe the contents and purpose of this variable. so that the user doesn't need to go back into the header file or the top of the file to look at the declarations and initializations and any comments there. Minimize the number of variables in scope. And this reduces the cognitive load of the reader. And this means you need to minimize the number of variables that are more global. Be mindful of temporary variables, only add those that help readability and add information. Temporaries that are just renaming variables and it's not really helping with readability should be avoided. Let's look at an example. This is a function that is written not to be misleading. All of the variable names make sense to the writer. And this is a pretty simple function. Let's spend 1 minute and can anyone tell me what this function is doing? Right, can anyone tell me what this function is doing? Yep. Some sort of numerical integration. How about this? Can you tell me more about this function? So this function does the definite integral from x left to x right. Originally, it's named a to b, which is how you would write in an integral formula. But if you name it like this, it's easier to understand for first-time readers. You have the integral itself to be returned. You have the step size. Usually we call it d, but if we just be explicit and call it step size. And there's the x1, x2, y average. And what this integral does is that it will do x2 equals to x1 plus step size, and we will be averaging the sum of 1 over x1 plus 1 over x2. So this is the definite integral that does integrate 1 over x from x1 to x2. So using this kind of variable names will help the readers to understand this function within 1 minute. Make descriptive variable names, often in multiple words. Discuss amongst your team to decide whether you want to use the underscores to separate words or use camel case. Remember, variables should be starting with a lowercase character. And be consistent within your team. All the variable names you are given should be following the same convention, the same as constants. Choose between starting with a K or all capitals. Be consistent. Type and class names should start with capital and following camel case. Let's look at this chunk of code that does find street segment length, taking in street segment index. Are there any thoughts on the coding style of this chunk of code? Any thoughts? Does this code look crowded? Yep. There's no spaces. No vertical white space. It's not dividing the code into code blocks. We'll need to break into paragraphs of related code. And adding the white spaces, it will look like this, which is cleaner. What else? How about the variables? Yep. Sorry, I can't hear. The variables are not very descriptive. And look at where they are defined. They're defined at the top of the function, but most of them are only used in one of the if and else. They're used only in some if-else branches, and this will introduce potential initialization bugs. Because length is defined outside of the if, but only used inside the if, not else. The other three are only used in the else, not if. So we want to avoid that and only declare variables at the smallest scope possible, where they can be initialized when they are used directly. So we move them into the if and else. And the variable names are not descriptive, as what you just said. Enter 1, enter 2, lat long 1, lat long 2. But enter 1 and enter 2 are obtained from info.from info.to. And there is a name loss of information. We are losing the information on from and to. And there are redundant temporary variables. Enter 1, enter 2 are only used in here. So there's no need of declaring enter 1, enter 2. What we need to do, use descriptive variable names and avoid the temporaries that are not improving clarity. It's just adding on more typing. So we rename the ID to street segment ID. As I said in the last tutorial, if it's a street segment index, make sure to have the name street segment, some sort of street segment inside the name. Segment info to segment info. Enter 1, enter 2 are removed, and we directly put info.from info.to into the get intersection position parameter field. And this reduced 2 lines already. And we rename the lat long 1, lat long 2 to position from, position 2. And length is also redundant. We can directly return from the function call. So now we shortens the if statement into 3 lines. Are the position from position 2 also redundant temporary variables? And should we eliminate those? Any thoughts? The pos from, pos to are also only declared and used once. Do we need to also eliminate those? If we do that, the code will look like this. So a single return statement will take 3 lines if we want to make it look clear enough. So this is not really necessary. Sometimes the temporary variables will improve the readability and add information, and allows you to better see your steps in the debugger. If you do this, and when you are stepping inside the debugger, you'll need to step into 3 times on this one line. But if we do this, you can see what happens on each line. So now we went from this to this. So it's way clearer and we have less lines of code. And that's it for variables. Any questions, comments? Next, comments. Let's see the type of comments that are already given in your code. On the top of the .h files, we have large block of comments saying what this header file contains and how would you use this header file. It usually contains the steps on how you would like to use this API. Function headers in the .h file. When you are defining each function in the .h file, there are lines of comments above it saying what this function does and how you would call it. Before structs and classes, we have large blocks of comments saying what this struct or class contains and how you would use it. And inside them, for each field, there's also description comments. On top of each code block, there's a line of comments saying what this code block does. Which of those are the most important to have in your code? Concept describes all the things inside the struct. There is one guideline to follow. The higher level comments are the most important. You should be having your documentations inside your code directly, not a separate document, because those will get out of date. But if it's directly inside your code, when you're changing your code, you will be changing your documentation. The most important comments give the big picture, and those describes the why. why we have the overall structure like this, and why we're choosing these design choices. Where to comment? The most important place to comment is in the top of files. We want to, at the top of each file you are creating, have a summary of what this file does. And then the class data structure definitions. When you're reading a piece of code, understanding data means you can understand most of the program. By looking at the data, most likely you will know what algorithm you're using. Declaration of functions in the .h file, how to call what it does. And then tricky bits of code, tricky blocks of code, comment them so that we know what these code are doing. This ranges from the most important to the least important. Do not leave commented out code in your project. Your TA will deduct marks for that. If you need to keep some of your code, Git has all of the code history, so don't leave commented out code in your project, especially at submissions. Do not translate clear code to English. We want to try to rewrite the tricky code into clear code first, and if you cannot do that, comment the tricky code. Let's look at the definite integral example again. And this is after we renamed all the variables so that it's easier to understand. How would you add comments to this function? What's the first comment you will add to this function? Yeah. Yep.
And then like you like one above like.
Yes. We will need high level comments at the top. And then we will have lines of comments at inside the for loop where the code could get tricky to read. Comment what the whole function does. That's the most important. And then comment any tricky bits of code. I need to fix the format. And that's it for comments. Next, duplicate code. Avoid duplicate code always, because it's likely going to be extracted into its own function. And it was likely copy-pasted by the programmer. If you are copy and pasting some bits of code in your program, be careful and think whether it can be extracted into its own function. The common source of bugs, the most common source of bug, is that when you are copy and pasting some bits of your code, and if you need to change something in those bits of code, and you forget to change one of those. Say in this for loop, we have a street segment info, and we're doing something on the from and the to. We're checking whether the ID is already inside the intersection ID, and if it's not, we push back. We see that these two chunks of code are almost identical, and that means there's duplicate code. The only difference are the ss.from, ss.to, and that's it. Extract those into a function. So we make a helper function called insert unique and pass in as parameters intersection 3 segments ss.from and the 3 segment ID. So now we effectively went from here to here. How about the comments after we factored out the two helper functions? Do we need to change the comments? So now we have two helper functions that in the name, it's pretty self-explanatory. So the comments are now becoming a bit wordy and repetitive. So we combine those two calls to the function into one code block, and we just say add 3 segment if it is not a duplicate. And it's very easy to read because it's just saying from and to in the call itself. And we made the comments into succinct, higher level comments that describes 2 lines. Just keep in mind, comments should describe why. And try not to be too repetitive and wordy. But at the top levels, be as detailed as possible. And next, I'll show you the IDE tools for code refactoring. I'll do the same thing in VS Code and in NetBeans. I'll do VS Code first because most of you most likely are using VS Code. So in this code, we have already implemented the same function as in the last tutorial, the finds 3 segments of intersection. And the code does the same thing as what we showed in the last tutorial. I'll prove that by doing a make. And ECE297 exercise 1. Run tester func. I'm using stars so that I don't need to worry about typing typos. So I'm passing one of the intersection tests, and that's the only function that we have implemented. Now, in the code for find 3 segments of intersection, we are doing a single return from the global variable. And in load map, we have this chunk of code, what's the first thing you notice about the coding style? Yeah. Yes. There's no vertical spaces. So anything else? The indentation is awful in here. What you can do in VS Code, highlight, right click, format selection. It fixes all the indentations. Hey, anything else? How about the variable names? This num equals to get num intersections. There is a clearly information lost in this name because this should be the number of intersections. Something you can do in VS Code is Control D, and this will highlight the next num. But this doesn't do any very intelligent algorithms. It just highlights the next one, and you can rename it like this. Or you can highlight this and right click and do rename symbol. This will do a very smart scope level rename, variable rename. So this will intelligently rename all the appearance of this variable in scope. Next, say I want to rename the I for intersection. Intersection ID. And X also has a lot of loss in information. Get non-intersection street segments. I can do Control D because we only have two occurrences, so I can just do street segment for the intersection. For J, J is the intersection street segment. And using that, I have renamed all the variables. Let's do a make and tester again to show that we didn't do anything to the functionality itself. We just fixed the coding style. Can we notice another thing about the coding style for this code? If we add other functions, in this case, we have only implemented one of the functions. If we want to implement all of the functions, what will load map look like? Load map will be longer and longer. So, because all of these code are doing one function, it's just loading up the global variable. Intersection 3 segments. We want to factor these into one helper function so that it's just one line calling the helper function to fill up one global variable. And do so for all of the global variables. And unfortunately, we don't have anything in VS Code to do the function refactoring, so you'll have to do it yourself, manually by hand. But we do have something like this in NetBeans. So I'll restore everything. And I'll do the same thing for NetBeans. M1.cpp load map. So we fix the vertical spacing and we fix the indentation by highlighting, right click, format. So this fixes the indentation. And if there are some white spaces between the assignments and comparisons, it also fixes those. Renames. Right click, refactor, rename. And we want to rename this to number intersections. Refactor. This does the same thing as what we just saw in VS Code. It does a very smart scope level renaming of the variable. And same for I. X. Okay. Refactor, rename. That's rename. After we rename, we want to factor this into a helper function. To do that, we highlight, right click again, refactor, introduce function. And it will ask for the name of the function. We'll just say fill intersection street segments. It asks for the return type. For this one, it's void. We're not returning anything. We're just doing one single action. And there are the parameters that you can define. In this case, we don't need any parameters, so we can refactor. And what it does, in load map, at the position of where the code was. It's just single call to the helper function. Helper function appears above. And then you should be adding the comments and vertical white spaces for the function itself. I'll save it and I'll make and test it to prove that I didn't change the functionality at all. And those are the tools that are there to help you do code refactoring. Now, next thing that's very important for coding style is to use named constants, not magic numbers. Every year, I see a lot of magic numbers, even though we're emphasizing this to the students. What does this code do? Returns a status code of 1 if all weights are positive, -1 if there is a negative number, or 0 if there is a 0 number occurring first. So it ends whenever it sees a negative value and returns -1, or it ends whenever it sees a 0 and returns 0. Otherwise, it returns 1. There are a lot of magic numbers here. The most obvious one is the 20, which is the size of the array that we're looking at. We see that the size occurred twice. So if we need to change the size of the array, we need to find and change all the 20s in here. If we miss any one of them, we'll get a bug. We're returning magic numbers -1, 0, and 1. The reader won't know what each means if they don't read through the code carefully. So we want to change those into named constants. We have 3 ways of making constants. To make a constant variable, const int num_weights equals to 20. So this variable is created on runtime. We can use a preprocessor constant using define weight 0, 0. This is created on compile time. Both works. And for something like -1, 0, and 1 that we're returning in this case, we can make an enum structure of the return variable. And we can either assign a value to the constants, or the enum can generate one for you. And you just need to refer it using the constant name. So then it's very easy to read what we are returning in this case. If we are getting a negative value, we're returning has negative. If we are getting a 0, we're returning has 0. And if we got through the for loop and we got to the return, we're returning all positive. So we have 3 ways to make constants all work. For our milestones, please use those. and not magic numbers. And one benefit of having the enum structure is that we can directly specify the return type to be the enum structure. And this constrains that only certain integers can be returned. So we have only -1, 0, and 1 defined in the enum. If we return a 2, then we know we have a mistake somewhere. And that's it for magic numbers. Any questions up to this point? Okay. Next, we want to eliminate your warnings. We want to make sure your code stays at 0 warnings. And this demo will show you why. So in here, we have the source file, checkwaits.cpp. And this is the same code as what I just showed. We are checking the weights and we are exiting if we see either a 0 or a negative value. And here's the array that we're passing in. We should be seeing a -1 as the first number, and we should be returning -1 according to the function. Let's see whether that's the case. No, actually. Giving makefile. Just want to show you the importance of warnings. I will disable all warnings in the makefile. So the -wall -w null sign compare will turn on all warnings. And in this case, I'm going to disable warnings by removing them. I'll save the makefile and I'll do a make clean and make again. So this compile has no errors. It succeeded with no errors. And let's run it. In our hypothesis, this should be returning a -1. But it's getting a 1. And why is that? Why do we get a 1 instead of a -1? Let's enable the warnings in the makefile. Do a make clean and make. We see that we are getting 1 compile warning saying in the function check weights on line 11, suggest parentheses around assignment used as truth value. So inside the if statement, we're doing an assignment where we were thinking that we are doing a comparison. Line 11. So we're missing an equal sign here. If this happens, even in this short chunk of code, it's very hard to realize. I'll save it and I'll do make again. Warning's gone. And when we do check numbers, -1. Some of the compile warnings are helpful to help you debug. We are asking you to don't have any warnings in your code, because warnings like what we just saw could flag potentially problematic code. If you leave some warnings that are not so important in, those important ones might be buried inside all of the warnings you're getting. So fix right away when you see a warning, stay at 0 warnings. This command g++-w enables all the warnings, and this is by default enabled in our makefile. Your TAs will look at how many warnings you're getting, and that is something that we'll be deducting. That's for warnings. Is it good? Group related data into classes. This is another very useful thing to have, but if you don't have it, you should be still grouping related data into chunks of code for your TA to read. Say we have these 4 vectors as global variables. These 4 vectors contain all informations about segments. But if we put them into a class of segment data, or you can use a struct for, in this case, that contains the first integer, float, double, integer, float, double. In this case, we can do the commenting inside here, and we only have one global vector on segment info. This is easier to read because you grouped related data and functions together, and it reduces name pollution. In this case, you have 4 names globally that you are not supposed to create variables of this name, of course, and you will need to remember these 4 names. But if you group them together, you only need to define segment info as global, and you can access 4 fields and whatever number of fields inside the class. And these names can be reused because they are fields inside the class. Next, defensive coding. Let your code find bugs for you. This is mostly optional in this course, but still very helpful to have. Use assertions to verify assumptions in your code. For find street segments of intersection, we are assuming that we are always having a valid intersection ID in the parameter. To be defensive enough, this function should be verifying that we are actually having a valid intersection ID at the beginning of the function by doing a assert. Assert the intersection ID is greater than or equal to 0, and it's less than intersection street segments dot size. This is our assumption, and we want to verify it. And without this, if you get an invalid intersection ID, your program will likely still access that piece of data. And it will either segfault in a later stage, or it will give you garbage data. And that's not what you want. If you add the assertion, you will know at which line, which assertion was failed directly from the program error message. So this will exit the program and tell you which assertion was failed. And this is, or it could even check whether the intersection street segments wasn't loaded before this function was called. It's better than a comment because it checks at runtime, always checks at runtime and gives useful error message. The only downside for assertions is that it adds on runtime to your program. It will slow your program down. So before your performance tests or before your submissions, add on this define and debug. This flag will turn off all of the assertions in your program. And make sure this line is before you do include assert.h. Assertions are not required for your mark, but this could be required if you are using pointers and if the pointer you are using may be reused later. When you delete a pointer, and that pointer is not going to be completely destroyed, that the pointer might be used later, always set the pointer back to now. Because if your code accidentally uses the pointer later, if you don't set it to now, your program will behave weirdly and it's a very hard to debug bug. If you set the pointer to now, whenever you access the pointer later, will segfault immediately. So it won't enter the next stage of your program and make it worse. C self-checking code is an advanced technique that we are not expecting you to use. You might use functions to do the validations of the data structures. And the reason why we are asking you to do the defensive coding is to avoid something like this. If your function could terminate or segfault before you're getting this, and in that case, you will fix it before it gets bad. Now I'll show the last demo. From what we had before. And I'll add the assertions to it. So for assertions, we'll need to do include assert.h. And inside finds three segments of intersection, we want to make sure that we are getting a valid intersection ID by having the assertion statement. Intersection ID is greater than or equal to 0, and intersection ID is less than the intersection's three segments of size. we do the assertion. Post these two, these three. And I'll do ECE297 -- round tester func intersection. So this assertion is still passing because the tester is not calling any invalid intersection IDs. And now, here's something that's pretty useful. Instead of -- round tester, move the terminal here. Instead of -- round tester, I do -- debug tester. And this, inside your tests folder, this will download the unit test source file into the test folder. For the test that I was running, the functionality intersection test for Toronto. So inside the file, we have the test suite, we have the base map fixture, and we have the map fixture, test fixture for intersection street segments test. Here are all the test cases. And afterwards, we have the other two tests that we have not implemented. So in this case, we could just delete them. And save. Then in the make file, configuration, we need to choose unit test, release debug, or debug check. I'll choose debug. Build target is all. Launch target, I'll choose test lib street map. This will go to the unit tests, to the make. And I'll launch the test. One test passed. We have one test. And now, let me try something that's out of the range of intersection IDs. Let me try -1. So this allows you to download the unit test file, and you can locally run the unit test files. And you can even create your own test cases. Do the make again. And run. Because we have a -1, the assertion is failing. In m1.cpp line 67, find three segments of intersection assertion, intersection ID greater than or equal to 0, and intersection ID is less than intersection street segments. The size failed. Abort. So this will not enter any later stage of your program, and it will stop right where it finds the problem. And it will tell you where it finds the problem. Usually if you then see something like this, the next step is to go to that line of code and do a debugger, or you can print out something that you should be looking for, like intersection ID, and the intersection 3segments.size to see which one of those was the problem. You can also turn off the assertion, as what I just said. Before you do the include assert.h, define and debug will disable all of the assertions in your code. So if I build and run again, because the assertion was turned off, it is not terminating where the assertion was. In this case, it actually is saying failure in intersection 3segments unhandled exception. And this is called in the unit test, check equal expected sorted finds 3segments of intersection -1. So this doesn't give as much information as this one. But we know this because of the -1 in this case, but usually it doesn't show as much information as the assertion. So make use of assertions in your code. Is that good? Just to summarize what we have just said, code will be read more than written by you, by others, so make it readable. You will forget what you wrote 1 week ago. So make it readable and make it understandable whenever you read again. Code will be modified many times, so make your functions small and avoid repeated code for the sake of later modifications. Keep the tests with the code so that the tests are always automated, so you can rerun often, and you can detect any potential bugs before they actually show up. Keep the documentation in your code using comments. Top-level comments are always more important than lower level. Do code reviews amongst your teammates. Read each other's code and discuss what is readable, what is not. According to Google, you should not commit any change until it's reviewed and approved by someone else. On Quarkus, we have the milestone 1 project management and code style rubric. I click on it. It's here. This is the rubric your TA is going to use. This doesn't include the full set of guidelines that I just said, but your TA will mark you based on that guideline. There are additional resources on coding style. And there is a coding style guide provided by Google, which could be useful in your future career. And that's it for today's tutorial. Thank you for coming. If you missed part of the tutorial, I will post the recordings online.